Now let's talk about how we can modulate the heart rate by increasing or decreasing these phases, by changing these phases. There are three ways to modulate the heart rate. First, we can decrease the steepness of phase 4, which will lead to increased time requirement to reach the threshold potential, and this will lead to decreased heart rate. Or we can increase the steepness of the phase 4, which will lead to less time requirement to reach the threshold potential, and this will increase the heart rate. We can decrease, second mechanism is that we can decrease the maximum diastolic potential and make it more negative. And third is the way where we can increase the threshold of action potential, that is, we can make it more positive or more negative. Now let's see what parasympathetic innervation does to the heart rate. The neurotransmitter in parasympathetic innervation is acetylcholine, which decreases the amount of CAMP, that is cyclic adenosine monophosphate, which leads to decreased amount of funny current. If the funny current activation is decreased, the steepness of phase 4 it decreases, leading to increased time requirement to reach the threshold potential. Also, it opens the potassium channel, that will increase the conductance of the conductance for the potassium, which will further lead to decreased maximum diastolic potential, like this. I'll show it here. And the third mechanism is that it decreases the calcium current, that is the calcium channel. It blocks the calcium channel, which decreases the steepness of phase 4 again. The phase 4 is comprised of both activation of funny current followed by the activation of calcium current. So it will lead to, altogether these three mechanisms will lead to increased time to reach threshold potential, and this will decrease the heart rate. Something like this. Now let's see what sympathetic innervation does to the heart rate. It increases the heart rate usually and increases the contractility of the myocardium. How does it do that? The neurotransmitter in sympathetic innervation is norepinephrine, which acts by beta-1 adrenergic receptors. It increases the heart rate by increasing the funny current activation, which will lead to the increased steepness of the phase 4, which will in turn lead to less time required to reach the action potential, and it also increases calcium channel in myocardium and nodal cells, which again leads to increased steepness of the phase 4. Altogether, this mechanism leads to increased heart rate. So what are the effects of parasympathetic and sympathetic activation on heart altogether? The parasympathetic activation will lead to decreased heart rate, and it will also lead to decreased conduction velocity through the AV node or AV junction. It doesn't affect the ventricular contraction or contractility because it doesn't innervate the ventricles. Now, what are the effects of sympathetic activation on heart? These are increased heart rate and increased contractility of ventricles also. Increased conduction velocity. I hope you can see that. Thank you.